Okay, good morning. It is March 1st. We are broadcasting in game first, and momentarily we will go inception. In game first, and momentarily we will go inception. In game first, and momentarily we will go inception. In game first, and momentarily we will go inception. In game first, and momentarily we will go inception. In game. Okay, we're double broadcasting in game and by YouTube. We're double broadcasting in game shut down and by inception effect. Double broadcasting is going to shut down and by inception effect. Double broadcasting. All right, double broadcasting in game. Let's transition. I guess we transition. There we go. Okay. And our music. Good morning, still double broadcasting. Okay, and we look okay. Let's single broadcast for a sec, and let's run through our different checklist for class today. Make sure we're ready to go technologically speaking with our infrastructure. So it is CS-030. Good morning. Let's make sure you've got a quiet location. Shut your door, shut your windows, tell your roommates you're in class so that they can stop their firework display. Put on your headphones if you've got them, so if you need to speak, you don't echo. Pull in Inception. Turn off notifications on your phone and your computer so you can focus for the duration of the class. I got mine off on my computer, and my phone is shut down as well. Let's open up Canvas and make sure we've got something we can look at for the content of our class. How are we doing on that? Okay, pretty good. There's our calendar. Good. Okay. Make sure that you have Eclipse open and that you've connected to Saros. We have got Saros up and running, and a few of you are on here. We'll go through there and connect everyone in a moment. Just to do a pass through here and get everyone that's on here to read only. That'd be Adeline, Ben Fernberg, Ben Ehrenchild, Landon, and Thomas for the time being. And we'll go ahead and try and add a few more people while we go through the rest of our checklist. All right, that's Eclipse and Saros. Make sure you've got your VPN activated. I have mine, so you can do voice in game. Open Firestorm, or we're already there. Go under Avatar and rebake your avatar. Avatar health, and force appearance update. And then make sure we're in the same environment. So go under World and Environment and make sure that you are midday, so we're all experiencing the same time in game. Make sure that your draw distance is set to something low. So if you move around, you can, it doesn't, not too laggy. You're in the classroom if you're here. Make sure you can see your classmates' names. And let's just walk, oops. Let's just, some pinged Ethan for some reason. Let me just walk around the room, see how we're doing. And you can see what I'm broadcasting here. All right. Good morning, Taylor. You look good over there. You are a dot. And Matthew as well. You guys need to rebake, please. Adeline, good morning. And Ben, good morning. Trent, Ethan, Frank, good morning. Got Sam, Thomas, and Dee Dee, good morning. Landon, Ethan Banez, Faith, Carson, and Ben. You know, one thing that I think is kind of interesting about this is, you know, you see this in physical classrooms as well. And in the virtual classroom, everyone ends up taking the same seat, which I think is crazy. It's interesting just how humans are. Ben and Carson, good morning. Josh, good morning. Morgan, good morning. We got Matthew moved over to this side. You violated the principle I just said. Luke and Ben, Bernie, good morning. And let's see, Dodger was stuck. So let's see if we can get Dodger moving around again. I might have to do something with Dodger. I think he's like sort of in permanent sitting mode there. I'm not sure what's going on. All right, great. Can someone please confirm that we're broadcasting okay? That you're, Matthew, you violated nothing serious. I was just saying that people all sit in the same seat in virtual world and in the real world. And I just think that's kind of interesting. And then when you showed up, you were over on my avatar's left, and then you moved over to the right. So, okay, thank you, Ethan, for confirming that you can hear and see what's happening. Let's go over to the calendar and see how we're doing on the calendar. Today is Monday, March 1st. Congratulations on making it to March. We're zoomed in broadcast. Let me do a full broadcast here. There we go. And great. Today is the first day that supposedly educators are allowed to get the vaccine. So I am eagerly trying to do that, although none of the websites have been updated. So I find myself in this strange position where when I go to sign up for a vaccine, try and get a vaccine, if I'm able to find one that's available. For example, this morning I was able to find one available in Santa Maria, which is like a 2-hour drive, but it's worth it if I could get it. You find yourself in a situation where the website asks you which of the following priority groups are you in? Are you over 65? Are you a healthcare worker? Do you work in a long-term care facility? And I find myself in an interesting position where the database is forcing me to lie because I can't actually select any of those options. And yet I know that California has authorized educators to have authorized educators to get the vaccine starting March 1st. So I'm put in a very odd situation by the computer systems where I have to decide how I'm going to respond to a database that forces me to lie. So what I did is I went ahead and I signed up as a long-term care facility member, and we are in contact with the pharmacy to try and verify that if we show up, we are eligible to get the vaccine, and if not, we'll relinquish our appointment. So anyway, it's a complicated world when you get stuck in these situations between policy and technical implementation and ethics to some degree. We are beginning chapter 15 today. So let me just reiterate, 15. Up till now, we've been going through our book in sequential order. And at this point, I'm going to make a jump to go out of order and move from chapter 7 to chapter 15. This is because it makes a little bit more sense logically to me. In the meantime, you all are working on chapter 7's Techne tonight, which is due tonight. And you've got an episteme due on Wednesday, which is your Twitter bot. I know a few of you, or at least in Slack, indicated some difficulty downloading the skeleton code from Canvas, and so I posted in Slack a copy of the same thing that is um, available on Canvas if Canvas is working correctly. That was Dee Dee that raised that. Thank you, Dee Dee, for bringing that up for the class. Um, so let's see how to move forward. Let me just do a quick example for you to help those of you who are feeling unsettled about the Chapter 7 programming assignment to understand a little bit of the structure of how to go about doing a project like that. Let me see about bringing the rest of us on board. So we're shifting over to Eclipse for a second, and those of you who have not connected yet, I will attempt to connect you again. Morgan, I'm going to send you to read only. Good, and Faith, I'm going to send you to read only. Sam, I'm going to send you to read only. Ethan Vaughn, read only. And I think that's everyone is connected so far, so good. All right, and we'll try and sign up Trent again, and Dee Dee, and Matthew, and Josh, and Frank, and Carson. And while those folks attempt to connect, what I want to do is I want to sort of give you an example of the skeleton code of what you're trying to do as you work through this particular example. And so when I think of it at kind of at an abstract level, and I don't think of it quite so specifically as dealing with Twitter or trying too much about trying to worry about what all the different classes are doing. So what I'm going to do to demonstrate this, I'm going to create a sample script, and let's take a scenario that okay, so GameStop has been in the news recently. Let's imagine that we're working with a bunch of people who have Robinhood accounts. Robinhood is an online brokerage service. You can buy and sell stocks with Robinhood, and one of the things that Robinhood introduced was the ability to buy fractional shares of stocks, which is great because if you have a very expensive stock like I think Apple is expensive, to buy one share can be several $100s, and people might not have that much money to initially invest. And so you can buy fractional shares, and that's something that is relatively new. So let's imagine that we have a bunch of accounts of, let's do a Robinhood example. And what we want to do is we want to imagine we're working in the Robinhood's environment, Robinhood's software environment, and we want to find all of the users who have game game GameStop stock. And we're going to do that by doing a process similar to the process that we used to that you're going to use to do the Twitter project. All right, I'm having a little bit of trouble speaking because it's early in the morning and because I got multiple things hitting me up with our synchronization here. All right. So in the Robinhood example, what I want to start with is I want to start with some pseudocode. Let me set some up to read only and then see what comments are. Is BRKA, is that our latest stock that we're pumping up? I don't even know what that is. I don't even know. I don't even know. All right, so here's the pseudocode. I'm going to do it in comments so you kind of get it set up. So the first one I'm going to do is I'm going to say obtain an array list of accounts. Loop through the accounts. If an account has GameStop stock, then add it to a list for processing. When I've looked at all the accounts, output the account numbers of the accounts with GameStop stock. All right, so then that's my basic pseudocode that I want to use. And so I'm going to just start building that out. I'm going to have to assume that there are some data structures that are available to me that are going to hold this kind of information. So the first thing I'm going to use is I'm going to create an array list like we've talked about. And what's in that array list, I'm going to call it accounts. It's giving me an error because I need to put something in this diamond notation, but we'll say accounts. And we're going to use some method that I don't really understand because I don't control all of this software. I'm going to use a library, and I'm going to say get all accounts. And that's going to return an array list filled with stock accounts, stock account type. All right, because that doesn't exist, I'm going to create one real quick abstractly. I don't want you to think about the stock account class because that is at like your status account in your Twitter assignment. You don't really know much about it, but you know what's in it. And let's give it some public interface. Let's say public get account number. Now it's going to return a string. We'll keep that count number as a string. That's a little counterintuitive since it's a number, but I'm returning a string, but we'll use it as a string anyway. And we'll use public Boolean has GameStop, has stock, and we'll pass it in the stock ticker of the stock we're interested in. All right. And so we're going to just, let's see. Stand by. I'll explain what I'm doing in a second. Okay, and let's see, get all accounts, and we'll say, okay, create a brokerage account. Sorry, I'm not explaining what I'm doing. I'm trying to go fast so that I can get it right and then go back and explain what's happening and not spend time on the things that don't matter for your understanding. But it's available if you want to look at it. All right, so I just made some stubbed out some code for us, and we need to include that. All right, so what I needed to do was I needed to create a little bit of a library that would create a brokerage account, a brokerage for us. So I made a brokerage class, and what the brokerage class does is well, okay, let's see. Let's do this properly. I guess if I'm going to teach you, I might as well do it the right way. All right, let's make a new brokerage. It's a little funny because you don't like make a new brokerage exactly, but all right. And then we will say private, make a constructor. Okay, see how that works. All right, so what I'm trying to do is create a little bit of infrastructure so that we can work through that pseudocode that starts on line 9 and continues to line 13. So in your homework assignment, what I'm asking you to do is to do a similar kind of work, but do it with Twitter accounts. And in this particular example, what I'm trying to do is provide a little bit of a library of how you would, do a similar thing, trying to find all the accounts that have GameStop stock in them. So I'm going to start with the brokerage B, and this is like that line 15 and line 17 is like the process in your code. You could replace that with the part of your code that goes out to a Twitter account and gets a list of statuses from one particular Twitter account. So in your code, in your example, the code from line 15 to 17 is going to include the scanner where you ask the user for the keyword and the scanner where you ask the user for the account that you're interested in, the configuration builder, the part where you go and you suck in all of the different Twitter accounts. And then at some point, you're going to have this array list that you want to work with, and you want to go through and you want to screen it. So obtain a list of accounts. All right, we did that. Now loop through the accounts. All right, so we're going to do that with a fast enumeration because we want to go through all of the different elements of accounts. And we know we want to go through all the elements of the accounts. And so we can start by saying, okay, colon, we need a variable before this, but we're going to colon, we're going to range over all of the accounts here. When we go through our data structure that is an array list of stock accounts, each thing that we go through, each time we go through our loop, each element in our array list is a stock account. In your case, each element that you go through will be a status. And so each time through the loop, I want a new variable, we'll call it account, which will be the next element in our array list of accounts. And so each pass through the loop, I have a new account that I get to work with. And what I'm interested in is I'm interested in this condition. If an account has GameStop stock in it, then I'm going to add it to another list for processing. Well, I need to have that list. I don't have such a list. So let me go ahead and make one. I'm going to do it up here where I was getting all the lists, just all the other ones, because it just kind of makes sense. I'm going to have a separate array list of stock accounts, which are, I don't know, accounts of interest, accounts with GME, we'll call it that. And we're going to say this is going to be an empty array list. And what is it going to contain? It's going to contain stock accounts also, but not as many. It's going to have a subset of the ones that are in the get all accounts. Broadcasting, okay. All right, and then each time I go through here, if an account has GameStop stock, then I'm going to add it to the list for processing. Okay, well that means that I have to check to see if it has GameStop stock. The way I do that is, in this case, I will say if account dot has stock, and I will pass it GameStop as the question, or as the stock I'm interested in. And if it does, then I'm going to add it to the accounts that I'm keeping track of, the subset of accounts, a separate list that is going to have just the accounts that are of interest to me. All right, now in the infrastructure here, this is when I get all my accounts, this is just 1,000 random accounts I made, and whether or not it has GameStop stock is a random decision as well for the library. But I don't know that. I don't know how it's implemented. All I care about is this work that I'm doing here in the main function of the Robinhood example, where I'm going through and I'm pulling out the accounts that have the GameStop stock. All right, so when I've looked at all the accounts, all right, so that means that I've gone through all of the accounts and I've added them to the separate list that I care about. Now I can output the account numbers of the accounts with GameStop stock. So to do that, I'm going to need a list to go through the accounts that a loop to go through the accounts that I care about that I've collected along the way. And so I will again go through and I will range over just the accounts with GameStop stock in it, which I just created. So now I have a new fast enumeration loop here starting at line 27. And each time I go through it, I'm going to go ahead and print out what the account number is. And so to do that, I need to know how to get the account number from here. And I'm going to call count.getAccountNumber. And let's put a little header on here. Let's do all right, we'll print that out at the top. Let's give it tab so it looks fancy. \T is a tab character. All right, and then have I done everything I wanted to do? API programmer. I'm going to do the work of setting up my system. I'm going to get all my accounts. I'm going to create an empty list to hold the ones that I care about. I'm going to go through all of the accounts. I'm then going to add a condition of the ones that I'm interested in to that condition. Those that meet the criteria of my condition on line 20, I'm going to add to the list on line 21 that's keeping track of those that meet the condition. When I'm done going through all of my baseline accounts at line 17, now I can go through and examine the ones that I collected and output what was there. So if I run this, let's see how it works. All right, pretty good. So open that up. There were 1,000 counts in it initially, and you can see that accounts with GME, it looks like probably about 500 actually ended up having GameStop stock in it. So there's a rough outline that is similar in spirit, at least at some level, to how you're going to go about doing your Chapter 7 homework. Any questions about that? Let me shift in-game to in-game audio to answer any questions. Broadcasting double. Chapter 15, not 8, chapter 15 is called the Java Collections Framework. And so what we're doing here is we've given you the opportunity to look at arrays and array list. Array list is the first example of something from the Java Collections Framework that we've worked with. There are other things from the Java Collection Framework besides array list. We're going to look at some of those in chapter 15. And then we're going to return back and we're going to look at arrays and we're going to look at array lists. And we're going to look at, in a future chapter, and we're going to look to see how we can implement an array list using arrays. So as we jump into a new chapter, we've got a couple things we need to take care of here. The first one is we need to do a Dodger report, and I also want to just open us in prayer for this content. So I'm going to read a prayer. It's called the Lenten Prayer of Saint Ephrem. We're in the second week of Lent now, I believe. Saint Ephrem is a Christian from the 4th century living in Syria, an area under much duress right now in our modern world. But it is a prayer that has been prayed during Lent for over 1700 years and counting, and that gives me pause sometimes and just puts my faith in context of a very long span of human history. And I think that's healthy because a lot of times we think of everything as being so immediate, especially working in a technological field. Everything's so immediate and new. And then there are these moments when you remember that people have been struggling with some of the same human struggles that we experience today for many thousands of years. So, all right, so I'm going to read, and if you just join me for a sec. A Lenten prayer from the 4th century. O Lord and Redeemer of my life, take from me the spirit of laziness, despair, lust, gossip, and pride. Replace each one with a spirit of humility, patience, purity, self-denial, with a love for what you love, and a burden for what burdens you. My Lord and Savior, help me to confront my own transgressions and not to condemn my brothers and sisters. For you alone are just and holy, now and forever. Amen. All right, thank you. Okay, Dodger report. As we get rolling to chapter 15, something I noticed about Dodger recently, knowing that I have to do the Dodger reports, I pay attention to Dodger a little bit more than maybe I might otherwise. We take off his collar at night because it's got his dog licenses on it, and when he stands up and shakes to sort of stretch out, he makes a bunch of noise. And while I can sleep through everything, the rest of my family, he sleeps in the hallway, but that adjoins all of our bedrooms. And so when he stands up and shakes with his collar on, sometimes he wakes up other people. So at night we take off his collar and he sleeps near it or by it. But he loves his collar. It's very funny. He really, really likes it. And so in the morning, whenever, when we get up, we put his collar back on before we get going for the day, just as we're walking by him to wake up. And it's like we put the collar on him, and he's like Chewbacca from Star Wars receiving some medal. He's just so proud to get the collar. And we took some pictures of him getting his collar on. It's like he becomes part of the pack again. He's proud of it. There he is, getting it from my wife this morning. The donning of the medals. Dun, da, 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 da. I am part of the family. So that's Dodger, and one of the things that he aspires to is to be part of the pack. He's always worried about being part of the pack. Okay, so the Java Collections Framework is about a library that comes with Java that implements many of the different data structures that we saw when we were working in Python, and many of the different data structures that are available just in all languages. Java does it in a very particular kind of way, and we're going to look at that. All right, so in this chapter, we want to think about how we can use these collection classes that are part of the Java library. We want to think about iterators, and iterators are a class that is helpful for doing loops over things. And so when you do fast enumeration is relying on iterators. We want to think about how to choose collections that are appropriate for the problems that we're facing, and to look at some applications of two particular collection frameworks, stacks and queues, which we have touched on briefly in previous classes. All right, so the Java Collections Framework is a collection of groups that work together that hold objects and allow them to be retrieved later. So collections is a name for what all of these different data structures are. They are collections of references to objects. They are collections, all of them, but they all have different kinds of contracts in that the way in which they organize the references and the way in which they are used by an API programmer varies. And the choice of which collection to make depends a lot on how well that collection matches to the structure of the data that you're looking at in the real world. So for example, in our consideration of using an array list maps well to something like maybe the drive-through line at In-N-Out. The drive-through line at In-N-Out has a bunch of cars in it. Those cars are in order, and we want to keep track of those cars, and we want to know which one's first and which one's second and which one's third, because that matters for servicing, taking their order, and delivering food. In contrast, there are other things that we might not care so much about. For example, maybe we want to keep track of how many people at Westmont have been vaccinated by the COVID vaccine. And in this case, it's not so important for the sake of knowing who's vaccinated to have an order. We might just want to know whether someone is in that group, in that collection, or not in that collection. You are vaccinated or you aren't vaccinated. In which case, an array list wouldn't be the appropriate data structure, but maybe a set would be an appropriate data structure. A data structure like a set keeps track of elements, keeps track of things that are in or out of a set, but doesn't keep track of an order. And by virtue of not having to keep track of an order, it can do that more efficiently and faster than a data structure that is maintaining an order, such as a set. So your choice of collections also impacts the efficiency of the data structure that you're using as well. It doesn't affect the efficiency of the data structure, but different data structures have different efficiencies. And so picking the one that has the best mapping to the kind of data, the properties of the data that you care about is the way to get the most efficiency out of your problem. Okay, so here is an inheritance hierarchy for the data for some of the collections in the Java collection framework, and I'm trying to make sure that you can see them okay. Let's see, I know that they're a little bit zoomed out. Let me zoom in a little bit just so we can talk about them for a sec. An inheritance hierarchy means that all the classes below um, have the same methods as the class above, but probably more. So it's an inheritance hierarchy in the same way as Python. Java has a little bit more nuanced approach to inheritance, and we'll look at that a little bit. So you can see over on the left at the top, there's something called a collection, and everything underneath there descends from the collection interface. So the far left on the bottom, we see array list. Array list is the first one that we've worked with. But there's also a sibling to array list called stack, and there's another sibling called a linked list, another sibling called a priority queue. We have a sibling called a hash set and tree set. And all of these descend from different interfaces. We can see list and queue and set. And in fact, you have seen a reference to the list interface from the software that we looked at last class in preparation for looking at the skeleton for the programming assignment for chapter 7. You saw that when I created an array list, I stored the reference in a variable whose type was simply list, not array list. And that was using the inheritance hierarchy that's present in Java to abstract away what kind of list we're working with. Over on the right, we see a different interface, the map interface. The map interface we've worked with as a dictionary in Python. Dictionaries and maps are the same things. Different languages use different names for them. Another name that you'll see for a dictionary or a map is an associative array. So different, let's see, Perl uses the term associative array. The Linden scripting language, which is the programming language used in OpenSim that we're currently doing our class in, uses associative array. Objective-C uses dictionary, Python uses dictionary, Java uses map. I can't remember what Swift uses. I think Swift uses dictionary because it sends from Objective-C. I don't think there are any other terms for this idea. But the idea is that you have a key and a value. And your key maps to your value. And this is a little bit different than a collection, which is why it has a different inheritance hierarchy. And it's different from a collection because a map doesn't just store one collection of things, it actually stores two collections of things, a collection of keys and a collection of values. And then it also keeps track of a relationship between the two. Much like a dictionary, a Webster's dictionary has both words and definitions, and then keeps a connection between the two, which word goes with which definition, or the way a phone book or your contact list in your phone has two sets of information. It has the name of your contact and then it has the contact information. The name of your contact is one collection, and then the contact information could be thought of as a second collection. And then there's a relationship between them that maps your contact name to the contact information. That's the difference with a map. All right, so our Java Collections framework is a hierarchy of interface instance types and classes that collect objects in different ways. And each one of these interfaces can be implemented by one or more classes. So if you decide you want a list, which is this abstract idea of an ordered collection of elements, you have to decide which kind of list you want to use. In this case, you can see that there are three possible options. There's an array list, a stack, and a linked list. And the choice has impacts for how efficiently they run. All right, collection is at the root. All collection classes have to implement the methods that are present in the collection interface. The fact that something is an interface means that it declares a set of methods, and everything below it has to have those methods in it. So let's look at the list interface and kind of get a little bit of a sense of what this inheritance hierarchy is doing for us. What the list interface does is it allows us to remember the order of our elements, and there are two possible classes that we could use to implement this. We can use an array list and we can use a linked list. So if we cut back over to our code here, and in our Robinhood example, let's see, down here, let's talk about here where we're working with our arrays with our GameStop stock. On the one hand, we have the option to keep track of we need to have a type for accounts with GME. And here we said that our type is an array list, and in our array list is stock accounts. And over on the right, we implemented it, or we instantiated it with a constructor on array list. We can keep track of this variable accounts with GME and say that it is just a list. We have to import it. And once we import it, we are now allowed to say that we are going to create an array list and we're going to store it in a reference whose type is list. If we go back to our slides here, you can see over here on the left, here's our array list. And because our list interface demands that everything below it has the methods that are in our list interface, we can have a list variable keeping track of any of the choices below it. So to just sort of cement that idea, we could, instead of using an array list, we could say, I would like to keep track of my list as a linked list, and I have to import that. Or I could keep track of a list as a stack. Oops. These are all choices with consequences, but for the purposes of compiling, you can see that a list variable can be assigned to anything that's below it. I liked array list, so that's good. Now, often what happens is that students will find themselves knowing they need a list and will try and create a list using what seems like a reasonable approach, which is to call a constructor on a list. And what you will encounter is that you cannot do this. You can't do this because list isn't an implementation, it is an interface. An interface is just a list of methods that all of the children of that interface have to implement. It's not actually code. It's just it's just a bunch of slots. It's just an interface, like we've been talking about an interface. We've talked about creating a public interface where you create public method names, and then we talk about implementing them. Well, an interface is just the method names. And so you can't actually create an object with just method names. You need it to be instantiated. You need it to be implemented. And so you have to choose a particular implementation of a list in order for this to compile. And you have choices about the implementation, but different implementations are implemented different ways, and so you have to pick one. You can always keep it more specific like this. You can keep the most specific type if you'd like, and that will still work, but then you have to say linked list and linked list. All right, so that works as well. Or you could say stack and stack. But I was intentional. Oops, let me leave that there so you can see that for comments. But that's actually what I want there. What you can see is that when I leave accounts with GME as a list type, none of the code below here breaks because all of the ways in which an array list can be manipulated are descended from the list type. At least all the things that list requires array list has. All right, that was a little bit crazy. Let me stop and see if you have any questions about this inheritance hierarchy, the idea of a list, the choice of an implementation versus an interface. And let me switch to in-game to see if you got anything. All right, and so for the double broadcast. Okay, and for the purposes of the recording, we had a question about what is motivating a choice between different implementations of the list. And the answer was that different operations in different kinds of lists are more efficient depending on which implementation you use. And we said briefly that it's faster to get a random element from an array list, and it is slower to insert and remove things. It is faster to insert and remove things in a linked list than it is to look at a particular element. We're going to look at that in our future class, in our future lectures. Okay, going back to our slide deck. So our list acts like, if you need a metaphor, let's talk about books. And a list acts like a stack of encyclopedias on a bookshelf. And that is that we have 10 elements. They are in order. They're in our bookshelf. We keep them in order. We keep track of them. Array list and linked list both implement this interface. All right, a set interface is a little bit different. It's more like my bookshelf, which is just a big old stack of books. And a set is an interface for an unordered collection of unique elements. And so what this means is that you decide whether or not something is present, but the ordering of those elements in the collection is not kept track of. Like we said with the vaccine example, or if we just said in the case of a library, you might just ask, do you have this book or don't you have this book? But where it is in the stack is not kept track of. So because of this, the ability to find, add, and remove elements is much faster because the underlying implementation doesn't also need to keep track of where in the list it is. And there are two implementations to do this. One is called a hash table, and the other is called a binary search tree. And which technology you use to implement your set is reflected in the name of the implementation that you choose. If you choose hash set, the set will be implemented with a hash table. And if you choose a tree set, the implementation will be kept track of with a binary search tree. We can look at that as well coming up. We will. All right, a stack, if again you use the metaphor of the books, is like a stack of books. And what's interesting about this is that you're only able to put things on the top or take things off the top of your list of books. Now you still have a list, it's just that the list kind of runs vertically in the metaphor. You know which element is at the bottom in second and third and fourth and fifth, but when you want to go manipulate this particular list, you're only able to put things on top or take things off the top. And that's a constraint that you use in order to get efficiency, because it means that your implementation doesn't have to efficiently support removing things or finding things from anywhere in the stack. It just has to keep track and support finding things at the top of the stack. And I was going to say something else about that. It's like a stack of pancakes, although a stack of pancakes isn't quite as good of an example because you can kind of like stick the fork through the whole stack of pancakes and win. But in a stack of books, it's harder to stick a fork through the whole stack. Let's see. What else was I going to say about the stack? You do keep track of things. You only take things off the top and bottom. Okay, I guess that's it. There's something else I was going to say, but lost my train of thought. All right, a queue is kind of like a list as well, or it's kind of like a stack. The difference between a queue and a stack is that a stack, you add and remove things from one side, the top, if you will. We say top, but there's really no top. We just imagine a top because of gravity. A queue, in contrast, is like a line at an airport or at a grocery store in the United States anyway, where when something comes into a queue, it goes in one side, and when something comes out of a queue, it comes out the other side. So basically, the first thing in is the first thing out, or we say FIFO, first in, first out, is what a queue is. That means that when you show up at the bank or a grocery store, if you're the first one in line, you're the first one to go through the line. If you're the first one at the bank, you're the first one to get out of the bank. If you're the first one at the Slurpee counter at 7-Eleven, you're the first one to get a Slurpee. In a stack, it's opposite, right? In a stack, the way it works, if you're the first one to show up at a stack, you're the last one to come out of a stack. And so we call that LIFO, last in, first out. No, did I do that right? Last in, first out. Yeah, LIFO, last in, first out. And so that would be something like, yeah, I don't know, stack of books. What's a good example of people? What's a LIFO example with people, where the first person in is the last one out? Um, I don't, I don't know. I can't like you going playing sardines maybe. Like the first one that ends up in when you're playing sardines, which is kind of hide and seek. The first one that shows up is the last one out. Maybe it's kind of a stack. Um, a priority queue is slightly different. A priority queue is more like an airline line where you have frequent flyers, or maybe like a vaccine line where you have different tiers. And the way a priority queue works is that everyone goes in at one side, but things get taken out according to their priority. So if you are a first class customer and you go and you get in line at an airline ticket counter or an airport, um, and you are a regular coach cattle class um, passenger on an airplane, it doesn't matter which order you all show up in. The first class passengers are going to get taken out first, and that's what a priority queue does. Within the within the category of first class passengers, it will be a queue. So the first class passenger will come out before the last first class passenger, but all first class passengers will come out before cattle class comes out. This is called the priority queue. It's useful in a lot of different circumstances, although it doesn't. We don't encounter this a whole lot because it's kind of a particularly undemocratic kind of approach to line keeping, and so we don't find it very often, except perhaps for when you're paying for premium kind of stuff. Um, and the airline example is the best one I can come up with. Sounded like someone had an example of LIFO for me. Let me see what you got. Nope, just typing. All right. All right, and then finally we've got the map. And the map is keeping track of an association between keys and values. We use the term dictionary in other languages because it's like it's keeping track of a word and a definition. If we want to use the example of the book, we can keep track of a key and a value. And in this case, a map might be keeping track of the UPC codes, the barcode that's present on books, or it's not UPC on a book, it's an ISBN code on a book. And so the ISBN code is like I think it's like a 9 or a 13-digit number. And those numbers are represented as a barcode so that they can be scanned efficiently. But what the barcode is representing is just the database number, an account number. And what a map would do is keep track of the number and which book it maps to. So perhaps it is the number 41 and the book is Alice in Wonderland. Or maybe it is maybe the number is 52 and the book is um, Every Moment Holy, which is a book I have on my desk here. And so the relationship is between keys and values. And so this is different than the collections because in one sense, we have a whole collection of keys. All of the ISBN codes, all of those numbers is one collection. And then we have a whole other collection, which is all of the books. And so a map really has two kinds of collections. We call one the keys and the other is the values. And there is an association between them. The keys are kept in a set for those of you who are tracking what I'm talking about here. All right, so let's see. If we look at some of the things that are common among the collection interface, I'm going to try and zoom in here. We said that every class, except the maps, implement the collection interface. And so let's think about what does the collection interface have? We know that we can keep track of a variable that is of type collection by using an implementation of anything that comes below it in the inheritance hierarchy. So the first line here, we did the trick that I showed you in Eclipse there, where what we're keeping track of is we're keeping track of a collection of strings. We're calling it COLL for collection. And we're assigning it, we're initializing it to a new array list. So that's going to call the constructor of array list, return a reference to array list, and it's going to store it in a variable which is a reference to a collection. Now when we do this, something happens to the way in which we can use this object. And what happens is, from this point on, we're only allowed to use the methods that are present in the collection class, which is at the top of the inheritance hierarchy. As you move down the inheritance hierarchy, you may add additional methods. For example, the list interface may require additional methods on top of what the collection required. And an array list may implement additional methods in addition to what both the collection and the list interface required. The array list also implements them. If we choose to use a variable type which is higher in the inheritance hierarchy than the object that we are instantiating, for example, what we're doing here on the first line, then in subsequent uses of the COLL variable, we may only use those methods that are part of the collection interface. And so in this particular slide, what you see going down the row is that we are only using methods from the collection interface, nothing specific to any of the subclasses. So in the second line, what we do is we reassign our variable COLL to a new object that we are instantiating here, calling the constructor on. Originally, collection was on the first row, we declare the variable and we initialize it. On the second row, there's no need to declare the variable anymore. We've already given that variable a type in the first row. And when we assign it to a new tree set, we're going to call the constructor for tree set. Collection is now going to point to that new object, and the previous object, which was called in the first row, that new array list object, where does that go? We don't have a reference to it anymore. It's a chunk of memory, and so it drifts off into space, like Major Tom, like Elon Musk's Tesla that he launched into space. It's drifting through the ether. There are no references to it. It's like a tree falling in the forest. Does anyone hear it? And what happens is the Java virtual machine, when it identifies chunks of memory that have no references to them anymore, it has something called a garbage collector, which is a process that runs and goes and finds all those little bits of memory, those Teslas floating through space. It grabs them and it recycles them for us. Garbage collection is a really interesting and powerful technology that was pretty new when Java was first being implemented. You can do whole courses on garbage collection technology if you find yourself probably in grad school, somewhere that has an expert in that. In our third line, we are going to call a method on our collection reference. And that method that we're going to call is the size method. What size returns is how many things are in our collection. And we're going to store that in a new integer with a primitive type int. I'm going to call that n, and that's going to keep track of how big our collection is. Now from this, what you deduce is that all classes that implement the collection interface must implement the size method. The array list implementation does, the tree list implementation does, all the ones that descended from collection do. And so you can always ask a collection, how big are you? And the way we do that is by calling the size method. We can store it if we are so desire. In the fourth row, we see another method that's common to all collections. We see that we can add things to our collection. In the first row, we said that what our collection contains is string. So when we call our add method on the fourth row, we must be adding strings to our collection. And so we're going to add the string Harry and we're going to add the string Sally. Now, by virtue of the fact that this compiles, or by looking at the documentation, you can see that the collection class requires that the add method be implemented by any of its descendants. So an array list adds, a tree set adds, a stack adds, a linked list adds, everything that descends from collection adds. But how it adds and what add means can mean different things in different implementations. For example, what it means to add something to an array list means to put it on the end of the list. But what it means to add something to a set means to just add it to the collection. And again, no ordering is retained. But there is some idea of adding to every kind of thing that descends from a collection. In the fifth line, we see that all implementations can have a string representation, which means that there's some way to take all of the data that's present in the collection and represent it as a string somehow. So if you have some kind of a list, what COLL.toString will return will something like over on the right column there where it says bracket Harry, comma Sally bracket. Each implementation is responsible for implementing how to represent itself as a string, but that's something that all collections must do. Down in the next line where we say system.out.println collections, What happens here in the Java language is that the toString method is going to be invoked on that collection so that println has something to print out. Println only knows how to print out strings. And so one of the things that Java does is that it says, okay, I need a string collection. You must provide me with some kind of string representation of what's inside you so that I can give it to println so that we can output that on the console. The next line shows that all implementations of a collection must implement the remove method. Collection.remove Harry, and you see that in addition to doing something that changes the collection, which in particular removes Harry from your collection, it also, in addition to mutating the object, which is what happens in the first line, mutating the object is one thing that the method does. The other thing that it does is it returns a Boolean about whether or not that element was in the collection and therefore was removed. And so you might ask to remove the element Tom from a collection, but if that element isn't there, then it has no mutation. There's no side effect to this request, and B will be false. But if Tom was present in your collection, then B will be true and it will be removed. And again, what it means to remove something from a collection varies depending on what the collection actually is. All collections implement contains, and so you can ask whether or not a collection contains a particular element, and it will return a value that's true or false. And in this particular code, you can see that we don't need to redefine Boolean B as a Boolean because we did that in the previous line. We just reassign what value it contains once we ask collection.contains Sally. It turns out that for all collections, you can also do a fast enumeration. So in the second to last line, you can see we do for string s ranges over all the elements of collection. Each time we pass through it, s will be the next element in our collection, which contains strings, which you see from the first row, and we can print out what that string is. In order to be able to do fast enumeration, collections must implement something called an iterator. That fast enumeration relies on the implementation of the iterator. And in the final line, you can see that we can call iterator as a method and receive a reference to an iterator. But we don't know what iterators do yet. We just know they have something to do with looping over the elements of a collection. In addition to all of the methods that are present in a collection, we may have more specific methods that are present to any of our descendants of collections. Okay, so that's a good place to stop for today. What we will do next class is we will look a little bit more in depth at these brackets and how they are used in order to declare what is present in all of these different collection implementations. The book calls it the diamond syntax, and what it is it's a programming language paradigm called generics. Generics meaning that ArrayList is a generic class. It can contain any kinds of thing. It's generic. Um, and then we specify what's in it with the diamond syntax. Okay, that was good. I really like Java collections. One thing that's happening here is we're shifting. We're shifting from talking about the real low-level syntax of loops and variables and primitive types, and we're moving into something that I get much more excited about in programming languages, which is data management, efficiency of data management, structures that we can use to do work in the world. And so I get energized by this. I like this a lot. Let's stop there. If you need to take off, feel free to take off. Let me go in game and see if you have any questions. And if you want to try again and share this code, I will be happy to try that in the waning moments here. Thank you for your attention. Again, today, for the purposes of the recording, today is March 1st, and we are looking at Chapter 15, the Java Collections Framework. Okay, ending the broadcast for March 1st, 2021. Dodgers fixed, class is over, chapter 15, Java Collections Framework. Let's go back to my Fortress of Solitude.